So welcome guys. Considering this topic, which is sum and product root of a quadratic equation. First and foremost, I would like to bring you back to the general form of a quadratic equation, which is always in this form. So let's have it as ax squared plus bx plus c equals to 0. And we also believe that by the use of completing the square method, the result we actually have is something of this nature. That is x is equals to minus b plus or minus square root of b squared minus 4ac then all over 2a. Now looking at this, what if I decide to tell you that the first solution of this, like this is the quadratic equation, and then we all believe that the solution is this. This is the final solution. The two roots for this quadratic expression or this quadratic equation is this result that we actually have here, such that the first result, which is x1, is always equals to a minus b plus, you take the positive part first, square root of b square minus 4ac over 2a. This is the first solution. And then the second solution is what? Is minus b. I've taken the positive part. Now, the next step I want to take is this negative part. So I have minus b minus square root of b square minus 4ac, then all over what? 2a. Now, when we are now dealing with the sum and product root, this is the root of this equation. Like if I give you a quadratic equation of 2x squared minus 3x plus 4, such that my a is 2, b is minus 3, and c is 4. If I insert it here, I will surely have two answers, right? For this, if I insert b as minus 3, a as 2, and c as 4, I can easily get the root of this equation. This is the first solution and this is the second solution. This is the first one and this is the second solution. These two solutions are called the roots of this quadratic equation. The roots of this quadratic equation are this result here and this result that we actually have here. So what if I sum them together? That is, if I do x1 plus x2, what will I have? And what if I do their product? What if we try their difference? So that is where I'm actually heading to. So if I decide to substitute this x1, let x1 represent alpha and let x2 represent beta. So we are familiar with these two symbols. So that means alpha represents minus b plus square root of b squared minus 4ac over 2a, and then beta represents the second solution, which is what? Minus b minus square root of b squared minus 4ac over 2a. This is alpha and this is beta. Now, alpha and beta are the roots. Alpha is a root, beta is also a root. If I ask you to find the sum of the root of this equation, that means I want to try alpha plus beta. What if I ask you to find their product, that is alpha beta? So in this case, I can easily tell you that we can actually try to simplify this further by saying that alpha plus beta simply implies my alpha represents minus b plus square root of b squared minus 4ac over 2a plus what is beta? Beta is minus b minus square root of b squared minus 4ac over 2a. So if I solve this further, I can try to simplify this. When I simplify this, I have the LCM as 2a. 2a cancel 2a, I have 1. 1 multiply this, I have minus b plus b squared minus 4ac. Then with this positive sign, 2a cancel 2a, I have this left, minus b minus square root of b squared minus 4ac. So we all know what this will lead to. Trivially speaking, positive b squared minus 4ac with this plus times minus, which is minus this, then it's cancel out. Whatever I have left is just minus b, plus times minus is minus, then with this b, I have minus b minus b. I have minus b left over 2a. So minus b is minus 2b over 2a. So 2 cancel 2, hence I have minus b over a. So trivially, I can easily tell you that alpha, the sum of these roots, alpha plus beta, is minus b over a. Very simple. So you have to do the same thing for the product. For the product, you have to multiply over here and then give the final result. If you multiply, you end up having c over a. You can also try alpha minus beta, and like that. Thank you. So In continuation, you already believe that the sum of roots of a quadratic equation is always minus b over a. That is their addition. This is a root, this is another root. When you sum it together, you have minus b over a. When you find the product, if you multiply it together, you are expected to have c over a. What if you try the subtraction? Take note, if you try the subtraction, you should have square root of b square minus 4ac over possibly over 2a. Let's try the subtraction. So okay, I can easily edit this from here. So let's try it from here. What if it was subtraction that was here? What if this was subtraction? That means I will have minus b minus b. That's plus b. This is gone. So whatever I'll be left with is just this over a. I'll be left with twice of this plus b square minus 4ac minus times minus is plus. So whatever I'll be left with is something of this nature. This is what I will have left. I'll have twice of square root of b square minus 4ac over 2a. So if this cancel this, I have the subtraction as square root of b square minus 4ac over a. So you can try this on your own. If you try their product, you have c over a. If you try the addition, you have minus b over a. If you try the subtraction, you have b square minus 4ac. So take note of these three things. These three things are very, very important. The sum, the product, and the difference. You need them all the time. Now let's consider a new page.